So we're starting chapter 8 now, and we're going to look at explicit and recursive formulas. This is something that you did in Algebra 1. I'm not sure if you did it in Algebra 2, but we're going to be revisiting it here in Trig because of some things. These formulas are sort of building blocks for what we need to do in chapter 8. So it says, consider the following sequences, describe the pattern in words, and give the next 3 terms. So when I look at this sequence, 2, 7, 12, 17, 22, I try to figure out what looks like it's happening here. First thing I always look to see is if I'm adding, subtracting, or multiplying, or dividing. Here I can tell that I've added 5, and here I've added 5, and here I've added 5, and I've done the same thing here. Every time that I went to the next term, I added 5. So my description would be add 5 to the previous term. So my next 3 terms, if I add 5 to 22, I get 27. If I add 5 to 27, I get 32. If I add 5 to 32, I get 37. Let's look at my next sequence. This one is decreasing. The numbers are getting smaller. Subtracted 6, minus 6, minus 6, minus 6. So subtract 6 from the previous term. Sometimes instead of saying subtract 6, we might say add negative 6. That is the same thing as subtracting 6. So when we subtract 6 from negative 6, we get negative 12. Subtract 6 from negative 12, I get negative 18. Subtract 6 from negative 18, I get negative 24. Alright, let's go to my next one. Alright, so for this sequence, looks like I go down by 20, but then I only go down by 10 and then by 5. So it must not just be subtracting. So then I'm going to see if it's multiplying or dividing. Just like up here, subtraction can also be written as addition. Division can also be written as multiplication. Division, remember, is multiplying by the reciprocal. So I can think of this as, to get from 40 to 20, I divided by 2, or I multiplied by a half. 20 divided by 2 is 10, or 20 times a half. 10 divided by 2 is 5, or 10 times a half. So I can say divide the previous term by 2, or I can say multiply the previous term by a half. So when I take 2.5 and I multiply it by a half, I can use a calculator if I want to for this one. 2.5 times a half is 0.5. I get 1.25. Multiply that by 0.5, and I get 0.625. Multiply that by a half, and I get 0.3125. An arithmetic sequence is a sequence in which the difference between consecutive terms is constant. So the first 2 we can say were arithmetic because the difference in each term was 5. Here the difference in each term was negative 6. here, my difference was, it was minus 10, I'm sorry, minus 20. I was looking ahead to the next one. This one was then minus 10. This was minus 5. This was minus 2.5. Notice this is not a constant difference. So this sequence here would not be considered arithmetic. Arithmetic is when you add to get to the next term. That's why I also had us right up here, add -6. Subtraction is a form of addition. So arithmetic sequence, add to get to the next term. And remember that subtraction is a form of addition. It's adding, the opposite. In order to write formulas for arithmetic sequences, all you need is the constant difference d and the first term a sub 1. So we come down here and we look at explicit formulas. Explicit formulas allow you to find any term in a sequence by substituting the term number wanted in for n. So a sub n means the nth term. It could be the 5th term, the 7th term, the 8th term. Is always the first term plus the constant difference times n minus 1. Now you might be wondering, well, why did we multiply it by n minus 1? Why isn't it just the constant difference times n? Well, because we already have the first term, and if we want the 8th term, we only need to go 7 more terms. So that's why it would be the constant difference times 8 minus 1, which is 7. So the first term plus the constant difference times n minus 1. Example 1 says, consider the formula, the explicit formula. A sub n is 15 plus 2 times n minus 1. I would like to make a note that sometimes explicit formulas, some people like to rewrite their explicit formula and get rid of the parentheses, and if you did that, we would have a sub n equals 15 plus 2n minus 2. All I did was take this 2 and I distributed it, and then they'll simplify it. 15 and negative 2 is 13 plus 2n. If it's written in this format, this is what we call the 0 term, as opposed to the first term. And because what comes before 1? 0. So this is the 0 term, and we're adding 2 n times. Here we're starting at the first term, and we're adding the constant difference, n minus 1 times. The difference between these two formulas is where we begin in the sequence. Here we're beginning at the first term. Here we're beginning a term back, like we're just starting one term earlier. So you can use either formula and you'll get the same answer. What is the value of the 4th term? That means we let n equal 4. Let's use this formula here. So a sub 4 equals 15 plus 2 times 4 minus 1. Notice it's not times 4, it's 4 minus 1, because we're starting at the first term, and we're adding the 2 n minus 1 times. So a sub 4 equals 15 plus 2 times 3. 15 plus 6 is 21. Now, if I had wanted to, I could have used this formula here. I'm going to do it in a different color. And this would be a sub 4, still n is 4, is 13. Notice I'm starting a term back, plus 2 times 4. Now I get 13 plus 8, and I still get 21. And that's because I started a term earlier. So these formulas are the same. This one starts with the first term, this one starts with the 0 term. Find a sub 8. A sub 8, again, I'm going to show you using both. A sub 8 is 15 plus 2 times 8 minus 1. So a sub 8 is 15 plus 2 times 7. I know that 2 times 7 is 14. 14 and 15 would be 29. If I did it using this formula, a sub 8 would be 13 plus 2 times 8. 13 plus 16 is 29. Either way, we get the same thing. All right. Recursive formulas always give the first term and then tell you how the next term is related to the previous term. Sort of like what we did when we described our pattern in words, when we said add 5 to the previous term, or add -6 to the previous term, or multiply by a half to the previous term. That's considered recursive because it's recurring. It's saying, I'll tell you what to do to the previous term. And the previous term is denoted with the symbol a sub n minus 1 because a sub n is the term we want. So a sub n is the term we want. A sub n minus 1 is the term before or the previous term. So don't let that n minus 1 subscript throw you. A subscript just tells you this is the, like if this was the 10th term, 10 minus 1 is 9. This would be the 9th term. 9 comes before 10. It's the previous term. So we're supposed to look at this. Well, let's first look at this general formula. A sub 1 is always the first term, and a sub n is the previous term plus whatever the constant difference is. D is the constant difference. Now, there are times where I have seen a recursive formula written as a sub 0 is the 0 term, and a sub n, though, is still the previous term plus d. This is really how it's supposed to be done, but I have seen that happen on occasion. Consider the recursive formula where the first term is 2. That's how I read that. I'm going to write it in words with that, how I would say that. First term is 2, and a sub n is the previous term plus 5. Previous term plus 5. I started to write the word 5 out. Let's do that. So describe the formula in words. We are going to add 5 to the previous term. The sequence begins at 2. Give the first 4 terms in the sequence. Well, the first term we know is 2. The next term would be 7. The next one would be 12. And the next one would be 17. All I did was add 5 to the previous term. Then it asks if you had to find the 100th term in a sequence, which formula would be easiest to use, explicit or recursive? Well, if I use recursive, I'm going to have to keep adding 5, and I'm going to just have to keep going until I get to the 100th term. That's going to take me a really, really long time. And so sometimes what I need to do is I need to take my my recursive formula, and I'm going to need to convert it to an explicit formula so that I can quickly find my 100th term. And that's where we'll start our next video.